Hey friends, my name is C and you're watching MakesItEasy, and welcome to a new video for IGCSE Maths today. We have the questions video for vectors. And this will be the last video for the playlist of IGCSE Maths, so thank you all for watching this playlist. But anyways, these questions are from DrFrostMaths, so I'll link it in the description for you to check it out. And before we get into it, don't forget to leave a like, subscribe, and ring the notification bell so you don't miss out on any future videos. And we'll get started with question 1. Given that A is 1, 4 and B is 3, 2, write A plus B as column vector. So A plus B is equal to 1, 4 plus 3, 2, right? So to add column vectors, we just add the respective rows. So we add 1 and 3 and 4 and 2. So they'll get us 4, 6, so that's A plus B. So 4, 6, like so. Question 2, work out the magnitude of A and give your answers as a set. So here we have A, and basically the magnitude, the symbol that denotes it is the modular symbol, like so. Basically two straight lines, like vertical lines. So the magnitude is basically the length of A, and to work out the length or the magnitude, we use Pythagoras theorem, which basically is the root of 5 squared, each component squared, 5 squared plus minus 2 squared. That would get you root 29, because 5 squared is 25 and 2 squared is, or like minus 2 squared is 4, so 25 plus 4 is 29. So this will be the magnitude, root 29. And number 3, write as a column vector 3b minus c. So we have b here and c, so it will be 3b, b is 1, 7, minus c is minus 7, 0. So we can now simplify to get 3, 21 minus 7, 0, and therefore we can just, as like just now, we can just do like add or minus respective rows. So the top row will be 3 minus 7 to get 10, right? Because 3 plus 7, so it'll be 10, and the bottom is 21 minus 0, or just 21, so it will be 10, 21, like so. And question 4, the point A has coordinates 4, 2, so this here is 4, 2. Work out the coordinates of point C. And we know that it's a parallelogram, so each side must be parallel. That means AB must be equal to DC, or AD must be equal to BC. So we're given AD, which we can go from here to here. And we're given AB, here to here, and AB, which is here to here, A to B. But we need to go from A to C. What we can do is that we can go from A to B and B to C. But because we know that B to C is parallel to A to D, that means they're both the same, so they both have this vector right here, or like we call it the direction vector. So the coordinates of C will be the coordinates of A, which is 4, 2, plus AB to go from A to B, which is 5, 3. And to go from B to C, which is basically A to D, which is 1, 2. 1, 2. Now we can just add the respective vectors or respective rows. To get on the top will be 5 plus 4 plus 1, 10. And bottom is 3 plus 2 plus 2, 7. So the coordinates of C, it will be 10, 7. In question 5, express in terms of A and B, A and or B, the vector EF. And we know that this is a regular hexagon, and this, because it is regular, that means that each side might be corresponded to other sides as they might be parallel. So for example, OA here is parallel to this side here and to this side here. That means all of these have 6A as the vector. Consequently, OB, this side here, is parallel to this one and this side. That means they must be 6B. So we know that EF is this direction right here. And we know that it's parallel to OA, and because it's a regular hexagon, that means EF equals OA, which is equal to 6A. And let me just use a new color, like a green color, so it'll be 6A, like so. EF equals 6A. And we have question 6, so ABCD is a parallelogram, and AB is parallel to DC and AD is parallel to BC. and we're given that what AB equals to and what AD equals to. Express BD in terms of P and Q. So we know AB equals P, and we have to find BA. Therefore, it's basically the opposite where we put a negative sign. So BA equals minus P. So therefore, BD equals, let me just put it here. Here, BD, it's equal to BA plus AD, which is minus P plus Q, which is basically Q minus P. It's the same way around. So Q minus P, like so. In question 7, the length of PQ is 3 cm. Find the length of PR. So it might look complicated at first, like all of these given vectors and different lengths, but we can see the last one here. PR equals 4PQ, and we're given PQ here, the length. So we basically can just use this formula here to show what the length of PR is. So PR equals 4PQ. PQ is 3 cm. That means that PR is just 4 times 3 to get 12. So 12 cm, like so, 12. So question 8. Express the vector xy in terms of a and b. Give the answers in the simplest form. So xy, it'll be this way plus this way, right? But we know that because going this way, the OX is 2a plus b. That means going from XO will be minus 2a minus b. So therefore, xy will be equal to minus 2a minus b plus 4a plus 3b. And we can now basically just simplify it. 4a minus 2a will get 2a, and 3b minus b will get 2b. But that is not the simplest form. We have to factorize the 2 to get 2 bracket a plus b, like so. 2 bracket a plus b. And question 9, OACB is a parallelogram. OA, this is. The point N divides AB in the ratio of 2 to 1. Write an expression for ON in terms of A and B. So we can just set up a few different measurements here. So we know that OA is A and OB is B. That means that we have to find what AN is, right? Actually, no, we have to first find what AB is, then what AN is, right? So AB is equal to B minus A. Because this is A, that means this way is minus A, right? Therefore, we know that AN is equal to, because we know that the point N divides AB in the ratio of 2 to 1, that means this side is 2, this is 1, and the whole length is equal to 3 parts. But AN is 2 parts, so it's 2 over 3, and it'll be 2 over 3B minus A, right? Therefore, ON is equal to OA plus AN. And we can also do the same way around for OB. We could find what OB is, which is just B, and we can find BN, like so, and then we can do OB plus BN. It's the same thing, but I just chose to do the other way. So OA equals A, as mentioned in the question, plus AN, which is this part here. So it'll be 2 over 3B minus 2 over 3A, which if you do 1 minus 2 over 3, you get 1 over 3. 1 over 3A plus 2 over 3B. And we can basically just simplify it by just factorizing 1 over 3. 1 over 3A plus 2B, like so. So 1 over 3A plus 2B, like so. In question 10, OABC is a parallelogram where OA equals A and OC equals C. P is on the point AB such that AB equals 1 over 4 AB. So AP equals 1 over 4 AB. Q is a point on OC such that OQ equals 2 over 3 OC. Find the terms of A and C, PQ. So we know a few things, right? So we have OA already, and then we know that because it's a parallelogram, that means this equals OA2, and this equals OC, that means this side here equals OC as well, right? So we know that AB, So we have to find AB to find AP, right? So AB is equal to minus A here, minus A. And OC is basically C plus C. And CB is the same as OA, which is plus A. And this cancels out, that means AB equals C. Therefore, AP equals 1 over 4C, as shown here. This side here and this one here, right? Then we have to find OC for this one, for OQ. And it's already, we know that it's C. So OQ is 2 over 3C. So now we can find PQ. PQ will be equal to the opposite of AP. So PQ will be minus 1 over 4C from this part here, plus this side here, which is minus A, and plus OQ, which is 2 over 3C, 2 over 3C. So now we just have to simplify it by doing 2 over 3C minus 1 over 4C minus A. And that will get an answer of 5 over 12, 5 over 12C minus 8, and that's the final answer. So PQ is 5 over 12C minus 8, like so. And question 11, so we have this diagram here. PQR is a triangle, so the midpoint of PQ is W, like so. And PW is A, that means that this is basically just A as well. A, right? So we have R, PRY is a straight line and R is a midpoint. That means RY is also B. And the rest you can just fill it up in a minute. Let's just do it now. So QX, so XR is 2 to 1, that means this is 2 and 1. So what we can do now is that we can find WX first, WX. So WX, like so. We can just do it, we can do it two ways. We can just go up and down, or down and up. But up and down is easier, so let's just do it that way. So going up, it will be WQ plus QX. But we have to find what QX is. But before that, we have to find what QR is, right? So QR equals this, like minus A plus B. So it's minus 2A plus B. And QX, you know that X is 2/3 down, 2/3 away down. So it'll be 2 over 3 minus 2A plus B, like so. So WX is equal to A from here minus 4 over 3 minus 4 over 3A plus 2 over 3B. And we can basically just simplify it by getting minus 1 over 3A plus 2 over 3B. And by just simplifying and factorizing, we get 1 over 3 minus A plus 2B, like so. So that's WX. And then we have to prove that it's a straight line, right? That means WXY is a straight line. That means we have to find WX, which we have already, and WY. And WY is just equal to this right here, minus A plus B plus B. So plus B equals minus A plus 2B. And since we have the same base vector, and WS is a scalar multiple, it has a scalar multiple of 1 over 3, that means that we have essentially proved it. And they are parallel because of the same vector. And W is a common point, like so. And question 12, OP equals P and OQ equals Q. Use a vector method to prove that QR is parallel to OP. So we can just do it multiple, we can just label it first. So this is P, and this is Q, like so. And OP equals 1 over 4 OM. So this is 1, and this is 3, like so, right? So now we can find what PN is. PN right here, PN is equal to minus P plus Q plus Q. So minus P plus 2Q. That means that PR is a half of that, right? PR, because we know that R is a midpoint of Pn from here. So that's PR. So QR is basically, this is Q, so this is minus Q plus OP, which is P, plus 1 over 2 times minus P plus 2Q, like so. So we can simplify it to get QR equals minus Q plus P minus 1 over 2P plus Q. And basically the Q cancel out to get 1 over 2P. So QR is 1 over 2P. And let me just write this out. So that's number 1, right? Now we have to find OP. OP is just P. So as you can see, they both have the same base vector, and that means that they are parallel. So then we can just put QED after putting a small sentence. And QED basically stands for, in Latin, it stands for quod error demonstratum, which basically means what needs to be shown has been shown. It's a fancy way of saying that I've shown it. And 13, E is a point on the diagram dB such as DE equals a third dB. Use the vector method to show that ABC is parallel to AD. So we can first find what BC is. BC. So BC equals to, from here to here, it's minus 12A this way, plus 3B, plus 18A. That will get you 6A plus 3B, or if you factorize it, 3 times 2A plus B. That's number 1. And AE is basically equal to AE here. It's here to here. And we know that DE equals a third dB. That means that it's basically AD plus DE. And we know that DE is a third AB, so dB. So third dB. So AD is 3B already, right? We know that. 3B plus a third. dB is equal to this minus this. So minus this plus this, right? So it would be 12A minus 3B. 12A minus 3B. And if you were to factorize it and just simplify everything, you get an answer of 2A plus B. And as a conclusion, since we have the same vector, the same base, that means that they both are parallel. And QED. And here we have a trapezium. Given that BM equals K times OC, where K is a scalar, we use a method to find K. So OA equals A, and OB equals B. So this is also B. So this is B, and this is A. So BM is basically, and we know that M is the midpoint of CD. So CD is basically B minus A, like this and this, right? So CM is basically a half of that. And so BM equals BC, which is A, plus CM, which is a half B minus a half A, to get half A plus B, or half A, half A plus half B, or half A plus B. So when we have BM, which is half A plus B, equals K times, what is OC? OC is just A, because it's a parallel, it's a trapezium, it's in a parallelogram. So which is A plus B. So it's A plus, it's not just A, it's A plus B, because it's from O, so O here and here. So it's A plus B. And we can see that K is basically 1 over 2, because they are the only constants. Therefore, K equals 1 over 2. So K equals 1 over 2. Moving on, we have question 15. OAB is a triangle. Show that OP equals x2a plus 3b, where x is a fraction to be found. So we can first find what AB is. So AB is equal to b minus a, right? It's the same as just now. Therefore, AP is equal to 3 over 5, because AP to PB is 3, 2. That means that this is 3, 2. So AP is 3 over the total. The total is 3 plus 2, which is 5. B minus A. And now what we can do is that we can find OP, right? Because we have to find OP. So OP equals OA, which is A, plus AP, which is 3 over 5B, minus 3 over 5A. And that will simplify into 2 over 5A plus 3 over 5B. And we can basically just factorize 1 over 5 to get 2A plus 3B. And basically x equals 1 over 5, and that's the answer. So x equals 1 over 5. And question 16, the point M lies on PR such as PM equals 2 over 3 PR. And the point N lies on PQ such as PN equals 1 over 3 PQ. Show that MN equals KA. So we know that, let's just do it here on top. So MN is basically minus PM plus PN, right? Because minus this would basically get us MP plus PN. We can basically just cancel out because of the triangular law of addition to get MN, right? So we have to look into minus PM plus PN. So minus PM plus PN will be equal to minus 2 over 3 PR plus 1 over 3 PQ. And let me just rearrange it to get this first. So it'll be 1 over 3 PQ. PQ is 3A plus 4B. Minus 2 over 3 PR. Like this. And now it's basically just rearranging and just collecting all terms together to simplify it. Therefore, MN equals, if you were to simplify it, you would get equal to 11 over 3A. Therefore, K is 11 over 3. So, in question 17, write the vector CK in terms of A and B. So we have AB equals B minus A. Therefore, 2AB equals 2B minus 2A. And we need that because we know that AB is a standard to the point K, so that AB equals BK. So we basically have this and this. So this is 1 and this is 2. Like in terms of parts, so like 1, 1, 1 part. And AB is this. That means that this right here is basically 2B minus 2A. So CK. So we have to go from CB to BK. Right? And this 2AB is basically BK. Therefore, CK is equal to CB, which is because it's a parallelogram and it's parallel, it'll be equal to A. So it'll be A plus BK, which is 2B plus 2B minus 2A. And if you were to simplify it, you would get minus A, so in new color, you would get minus A plus 2B, like so. So CK is minus A plus 2B, like so. And last question, question 18. Express OC in terms of A and B. Given that AB to BC is 2 to 5. So AB here to 5. Right, so AB equals 3A plus 2B. 3A plus 2B minus 2A minus B. Just because it's basically minus this. And if you were to simplify, you would get A plus B. So we know that it's 2 to 5, right? AB to BC is 2 to 5. That means that BC is basically 5 over 2. Because we know that this is equal to 2 parts, and you have to find what the 5 parts are. So we can just basically divide this by 2 first, divide this by 2 to get what 1 part is, and multiply it by 5 to get 5 parts. That means it's basically divide by 2 times 5. divide by 2 here, and times by 5. So it'll be 5 over 2a plus b, like so, right? And OC is specifically just OB plus BC. So OC equals OB, 3 plus 2b, plus AA plus BC, which is 5 over 2a, plus 5 over 2b. And if you were to simplify this, you get 9 over 2a, plus 7 over 2b. And that's the final answer. So OC equals, actually no, I think I can further simplify this, but yeah, I think I can. So what I can do is that I can just factorize the 1 over 2. So 1 over 2, 9a plus 7b, like so. So OC equals 1 over 2, 9a plus 7b. So 9a plus 7b. And that's the final answer. And that's it for this questions video for IGCSE and Maths, but today we look into vectors. And I hope you'll find it useful and helpful, and if you did, please leave a like and subscribe and ring the notification bell so you don't miss out on any future videos. And if you have any comments or constructive feedback about my channel or my YouTube or my Instagram, you can comment down below and I'll reply to them. And check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.makesiteasy.com. And I hope you find it useful and helpful, and I'll see you all in the next video, which will be a completely new series because this video is the last video for the IGCSE and Maths playlist. So thank you all for watching this playlist, and I really appreciate all of your support. And if you find my channel helpful, don't forget to share it with your friends or anyone who might benefit from it. But until then, stay safe and happy learning, and see you in the next playlist.